So the lesson that we are going to do today is indirect proof. An indirect proof is a proof in which a statement is proven true by showing that its negation is false. Sounds kind of weird, but it really isn't so bad. So the method that we're going to use is if we want to prove that a statement, we'll call it P. If we want to prove that P is true, what we're going to do is we're going to assume that not P is true. Remember, assuming assumptions aren't good things to do. So by making an assumption, we're going to go through the proof and we're going to show that there is a contradiction somewhere in the body of your proof. And if you have a contradiction, then you need to conclude that not P really is false. And if not P is false, then regular P must be true. Okay, so it might sound kind of confusing, but you're going to pick up pretty quickly. So you always need to have a proof. Let me just move this out of the way. Okay, so we're trying to prove C. We said that the first thing you always have to do is to make an assumption, and you want to actually negate what you're trying to prove. So let's assume that C is not true. Again, the reason wasn't given. We are assuming it. It's considered to be an assumption. So we assume that not C is true. Well, when we look into the proof or to the givens, we know that not C would have to be used next with G. Let me erase that. Would have to be used with if G then C. Let me erase both of these. So we've got not C, and then we're going to use the second line is if G then C. We know that's true because it's given. And then from lines 1 and 2, by using modus tollens, we can now say not G is also true. Going back to the givens, we can now use the given of T or G. From 3 and 4, using disjunctive inference, that we know T is true. So that's 3 and 4. Go back up to the givens. I have to use all of them, and the one that I haven't used yet is not T. Not T is given. And then you should sort of be scratching your head and saying, well, wait a minute. We know that not T is true because it was given, but we prove with laws of logic that T was true. So we've got this contradiction here, and with the contradiction that's right here, we then have to say, well, hold on, what I assumed to be true, not C, is in fact false. So what I was trying to prove from the beginning, C, is true, and it's all true because of the contradiction. And that becomes 5 and 6. Okay? All right, let's take a look at the next one. So we're trying to prove F, which means we're going to start off with the assumption that not F is true. In the givens, not F can only be used with F or S. Through the law of the disjunctive inference, we know that S is true. Going back up to the givens, I know that if S, then B is true. Using the law of detachment, B is going to come off. Going back to your givens, you've got if B, then not P. In this case, detachment again gives you not P. And that's from 5 and 6. And then using modus tollens, nope, hold on, where am I right now? Not using modus tollens, going back to the given, sorry. Going back to the given, let me go up a little bit. I see that P is in fact true, which poses a big problem because I can't have P and not P be true. So then what I was trying to prove, or what I was assuming to be not true in the beginning is actually negated, which means F is in fact the true statement, and that's all due to the contradiction from 7 and 8. Okay, let's see if you can sort of see this whole thing. That kind of slides up the top a little bit. All right, hopefully that's okay. All right, let's go for this last guy. So we're trying to, let me get this piece out of the way. Okay, we're trying to prove not D, and we're doing it indirectly, by the way. So all of these, they'll tell you whether it's indirect or direct. So we're going to have to assume that the opposite of not D, which is D. There's your assumption. And then what's going to work with D, and it's going to be the if D, then C. And then laws of logic, I'm going to detach out my C. And then from there, the only thing that has a C in it is that first thing where it's A and B, or if A and B, I should say, then not C, and that's given. Now here's where it's a little bit tricky, but I think you're going to be fine. We can use the law of modus tollens again, because look what's happening. We've got the backs being opposite. So with modus tollens, we now need to negate the front. And negating the front is just going to look like the negation of A and B. So this is modus tollens. And that's from 3 and 4. And now what do we do here but distribute or use De Morgan's law, becoming not A or not B. And that's just from one line. Now I can go back up to my givens, and I've got either A or B still left. Doesn't matter which letter you choose. I'm going to choose A, which is given. I'm going to use disjunctive inference and say that not B is true. And that's from 6 and 7. I'm going to go back up to my givens because every given always has to be used in every proof. Number 9 is B because it's given. And then once again, there's a contradiction. The fact that 8 and 9 contradict themselves, then I have to say that my assumption is incorrect and not D is really the correct answer. Contradiction. And that's from 8 and 9. Okay, so again, it's basically a normal proof, except you're doing it indirectly. And all indirect proofs always start with the negation of what the proof statement is, or which is the assumption, all the way down to a contradiction. All right, so good luck.